So thanks for the presentation, for the invitation. Yeah, that's going to be the second part of my talk. Before getting to that, I'd like to share some of the experience in the research and innovation community, covering some of our work and not at the intersection of machine learning and networks. Coming at this point in the day, some things have already been covered, so I'll try not to repeat the same thing. And then I'll zoom in some of the use cases as well and try to go some lesson learned. Well, I think you're all pretty familiar with this today, so that which motivates the need of ML. The fact that telco networks are not really networks today anymore. They're a complex ecosystem which is composed of many pieces. We have seen some zoom in some of these pieces of the network today, but think of the access of the user can access with multiple devices, the home, the phone. There are a lot of IoT now, industrial IoT. And here a complex ecosystem with different actors. Then you have the access. We talk a lot about today the wireless access, but there is the fixed access as well. And for some companies, you have multiple ISP and multiple MNO, even within the same organization. So different teams, they can talk to each other. And then there's core network managed by another party. Then there is the platforms, IoT platform, roaming platform, edge computing platform. So you see complex ecosystem, even within the same company, different teams, not necessarily talking to each other, potentially multiple companies. So what I'm going to here is that operation might somehow reach some of the limits or get some into trouble here, and can machine learning and deep learning somehow help in this context. And I put both a question mark and exclamation marks because I think there are some proof points where actually it's helping, but there's also quite some questions there, and I think many have already been raised that I'll try to cover some of that. So the way I like to talk about this intersection of AI and ML, AI and networks, it's dividing it into two parts. So the first one is, most of the previous talk I've been talking about that, is that how the intelligence or AI can help network. Okay, let me give you 3 examples. So one is about platform. So there is a lot of today deployment of cloud and edge platform, different actors there. And there has been quite some work in showing how machine learning, deep learning can help orchestration or resource allocation in this context with different tools. One of the latest that has been used about reinforcement learning, which can learn the best strategy on the fly. And we're hearing about this lately. We have actually some work on that. I'm happy to talk about more later. Or think for IoT platform, basically sells IoT connectivity or IoT management service. There are 2 important pieces there. One hand, operation can get some help from machine learning to understand what's going on, because very often, especially if you talk about devices connected with global SIM, you don't control the full end-to-end. You just have a partial view of the system, but you encompass multiple ecosystems. So understand what's going on. Anomaly detection there is very important. And that actually is where some deep learning can help border simple techniques because of the complexity of the data. Or, for instance, can be used for giving added values to customers, giving you, okay, I can tell you about your trending, I can tell you where you're going, I can help you with the anomalies. So these are some cases which are actually relevant in the platform domain of the previous picture. Well, actually, this is sort of going to the direction of the previous talk about quality of service and quality of experience. Especially as telco provider, it's very important to try to understand the quality of service of experience of the user, but very often you don't have access to their phone. You don't have an application on their phone to look at that. So there has been some work, actually we did some work on that as well. Happy to share more about that, to get the quality from the network data itself. Doing, of course, some previous training with controlled experiments, and then try to apply that. Actually, this seems to be quite effective on both fixed and mobile networks. And they don't even have to necessarily use very complex model, but with some XGBoost or simple models actually works fairly well there. But also, it's important in this case to detect anomalies, especially in the quality, because these are not, very often, most of the cases, the quality is good. It's just some drop sometimes, but that's what you actually want to avoid, to have these interruptions. So being able to detect and react in this case, it's very important. And then, yeah, edge and core networks. There are typically 3 things that I've used for planning. So given the current training, if I have to plan the network, where I'm going to plan, and where I'm going to place the new device, the new hardware, and et cetera. Operations, so again, anomaly detection, resource allocation, scheduling, where do I send my packets to, or management. So here are some of the examples of that I've been popular in the research and innovation community. We've worked on some of those. But there is another part that I'm not sure I heard about this today, is actually how network can help intelligence. How can network help artificial intelligence? And I'm going to like to put here 2 examples. So one is about, it's again a distributed infrastructure, and you can deploy processing capabilities in different pieces of that. And actually AI-based application like XR, VR, or speech-to-text, or this kind of application might benefit a lot if they do not have to run in the cloud platform and move it towards the edge. The question is, where do you place that to find the best cost-benefit trade-off? But here, the network can actually play an important role. Think today about, all the talking about metaverse and this kind of application, actually where the network can be, play a key role again, probably here, and these kinds. So we actually have some work on this space as well. And another thing is that the network might not only be used for inference, but actually be used for training. You might not want to concentrate off the data for privacy reasons. I'm going to get to that later part of the talk, but also for processing reasons. What if I use and I reduce the amount of data I move and do some processing distributedly so that I don't overload part of the network. And this is another example of where these can, machine learning can help. So actually, network can help machine learning. So the other way around. Okay, now let me zoom in into one specific use case, which I found it cool because of the environment. So we had this project, which is about bringing connectivity in remote and connect areas in Latin America. And basically there the project was an infrastructure project, so provide an infrastructure where MNO can come and run their service on the top of it. It's based on a revenue share model with a lot of focus on open access technology. Now, here this infrastructure is about thousands of small communities, 2, 3, and 4G. But these are very remote, like some are in the jungle, some are in the mountain. But the interesting thing is that most of them are actually far away from the main road. So it's very hard to reach them, and very interesting scenarios. Different power supplies, from battery to solar panel, some of them, the lucky one with power grid. Different backhaul, you can imagine radio links, satellites, or again, the lucky one with fiber, but not many of them. So you can imagine operating these networks fairly complex, especially because of the intervention. So most of the intervention, they try to make it from remote as much as possible and delay as much as possible the intervention on site because that's costly. And you might not know exactly what to carry, and carrying without the main rod might be complicated as well. And also try to batch them together. So, especially in this context, it's very important to take into account the cost given the revenues that you can get in this kind of scenario. So the project takes a heavy data-driven approach from the beginning, building a sort of a data lake, collecting a lot of collecting statistics from the different cell sites with different vendors, and sort of normalize all of those and collect and place them in a sort of data lake, centralized, where you can actually do processing on the top of that, and try to extract as much value as possible for the operation from that. And talking about explainability, here are the OSS application that built on the top. So, okay, you might be very familiar with the diagnostic dashboard, monitoring dashboard, but it's very interesting. They also developed a rural bot, which was telling the operation what's the next intervention you might want to do. So this is a kind of interface that the insights from the network are used to display and making useful information to the operation. And on top of that, of course, you can see the different models that you can apply on this data to then nourish this tool in front of that. And with our different KPIs. And so one of the problems that we worked with them is that they seem to have, fluctuating failure, but not lasting a lot of time. The problem is that there is a high churn in this area, so you don't want to delay an intervention too much not to lose customer. But again, scheduled intervention might take quite a few hours to get there. You might get there and the failure will already be fixed by itself without any intervention. So actually, if you look at 5 months of data collected in this kind of environment, I don't want to annoy you with graph, but what I takeaways here is that 90% of this failure lasts less than 1 hour, and 99% of them is actually less than 24 hours. So even if you schedule twice a day the intervention, you might go there the day after and the failure is gone. And what's another interesting insight is that while failure might not last that much, there might be continuous failure on a single site. And this is, again, something that needs to be fixed, even if it's not continuous. But you don't want to fix something which gets fixed by itself quickly, or it's just a matter of a few days. So what they wanted to build is a model which tells you, should I go or not, instead of waiting a given threshold, that was typically set on 24 hours before, which was given again. So differently from all what I heard today, this is actually a supervised problem because we have labels, and we're very lucky. And so we tried different techniques for that, starting from machine learning to deep learning. It turns out that deep learning could provide, especially sort of LSTM or variants of it, could provide better benefit, slightly better performance, but the cost of installing GPUs and running all of that was, overcoming the benefits you could get. So they prefer to stick with the more simple machine learning XGBoost model. Important thing I forgot to tell you, they don't care about precision recall, they care about money. So is this gonna cost more or less? We can tell, I mean, of course they care about precision or recall, but what in the end matters is that you have to save money with respect to the baseline scenario. So we use this as a proxy. We didn't include this as in the cost function specifically, we use it as a proxy because it was a simple approximation. And that's why I have this graph of revenue here on my right-hand side. So the second important thing is that in the process, we developed some heuristic which are actually pretty good anyway. So even just in the process of building the model, we give a useful insight that could actually be deployed. Sometimes working better, working better than the model, no, but sometimes you might not need the model for that. And actual results were fairly good in the sense that we could get between 5 and 20%. That also depends a lot on the cell, on the value of the cell with respect to the cost of intervention, which means the location. But these were the results. So here, I put here a reference of paper we have about that. If you want to have a look more into details, I'm happy to chat more about that. So overall of this, coming back to the main plot of the talk, it's about this interaction of machine learning and networks. Here are some of the lessons learned that we have seen in the research and innovation community, as well as our work. And some have already been talked quite a bit about the global holistic end-to-end approach. I don't think we are yet there. There are many silos to be broken. So there are proof that in some use cases in silos work, but having a global end-to-end approach, it would be better, though that's not straightforward even within the same company, and that's something that probably we have to take into account. We talk a lot about usability and explainability. That's why I stressed a lot how we use that model, how we talk with operation of that, but we heard from others before the importance of this future scoring and to tell exactly what to do and the root cause in terms that network engineers could understand without having to deal with KDL divergence scores. Story of our life, the complexity of the data and the lack of data and the quality and the noise. I think that with respect to other fields like computer visions or traditional machine learning, we are a bit behind on that. It's because the network was not taught as a data in the first place, and we are building it on the top. Now, the next generation network will probably be taught about that, but we are not there yet. Here is the reason of my question about the coexistence with traditional approaches. It's because we keep running in the same troubles, and that's why it was sometimes heuristic was better or not, and what to use is a typical discussion that you might have, and it's super important to also be realize that ML is not the answer to all of your questions, and actually this should complement what's there, but may not be there. Which comes to robustness. I think we were talking at lunch about, talking about with security teams, giving them a 90% precision, they might not really be happy at all, and even with 99% precision. So for others, they might be okay, but for other use cases, no. That's about the robustness, which is, I think, an important piece to take into account when you design this system. Two things that I've not heard today, but are very important. So one is sustainability, and here I have two directions. The good one is about greening and not making lower energy and the lower footprint for the planet. Some of the algorithms, especially deep learning one and the heavy one, generates a lot and consume a lot of energy. I don't think at network we are still there because there are very few deep learning models, but it's very important to take into account this trade-off when developers do them. So is it worth in terms of energy? But apart from that, also the cost. And the cost can be in the cost of energy, but can be in the cost of infrastructure. You might don't want to, for a problem where XGBoost is 2% less good, as the example I told you earlier, to develop like 10 GPUs and run that because of the cost reason. So it's something that should be a design parameter as well. And I think that also other communities are realizing that and going towards that direction. It's something that we probably have to take into account. Given that we have other tools which works well, very often got back to the problem of the coexistence with traditional tool. And about accountability, transparency, and fairness. Why wondering, these are network data, KPIs might not carry. So first thing, it's not true that might not carry. There might be some stuff that you can figure out from there. About the user, telco data are complex. There is a lot of things that have to do with user data, though it's not only radio KPI. And then even working with these, you might create some bias in the model, even using the network data itself. assume that you take some decision at the radio level that might impact some decision in some area, which might be disfavored with respect to other, or you might favor some customer on board. So this fairness is important to take into account, which comes back to the accountability and transparency. So how these have been taken on, how we can explain. I think these are important aspects that as we are, in this journey, it's important to take into account, even in the context of telco networks. Now, you might have said you didn't talk about privacy yet. Yes, let me get there. And the question is, how can we, make sure that we don't hurt privacy and security of data and of the user, actually. And then, yeah, I mean, good news is that there is quite some work in the community and different communities about how we can protect privacy of the user and security, and I'm going to list some of those there, though I think it's not super explored yet in the context of Telco network, probably because we are a bit behind in some other scope, but I think it's important to take them into account. Which brings me to this picture that we call this federated learning as a service. It's a sort of a, infrastructure that we could envision as a potential evolution. And it has three components. I'm going to dig a bit more into one of those. And the first one is about federated learning. And again, the idea here is that you might not want to move the data from the user to a centralized cloud, and that would be a first important step towards privacy of the user that keeps in control of the user. And you train the model distributed, you only aggregate the results in the weight, and with some iteration, you get very close to the performance of a centralized model, or sometimes even the same. This might not be enough, but it's a good first step. There are two other approaches that we have been explored and the community has explored. It's about, so one is to add in noise at different points in the pipeline at different levels of the network so that you can preserve the user privacy while still getting some decent performance in the model, though it's typically differential privacy noise problem. It's good, but it's still hurting quite a bit the performance of the user, I would say, the performance of the model, sorry. And then there are trusted execution environments. So putting all of this together, it's a way to get toward it. I'm going to give you some example of those later on. But the idea is that, okay, you can do that on the devices, but also some network data in the user house or different places and doing that hierarchically. So this is a way, an architecture that could protect user privacies in different way. Now let me zoom in into specifically the federated learning and the TEs. So federated learning, I told you, it's a way that you don't move the data from the users, you just send the server sort of, it starts a process, it boots up the model, and then local training on some of the devices, they send back the weights of the model, and then this iterates a bit, and then you get back to the funnel to the user. And this is good because data doesn't move, but there have been attacks like data reconstruction attack, property fields attack, and membership fields attack that's been shown possible only looking at the weights, which comes from the user. So the centralized server, if you don't trust the honest, but could potentially reconstruct the model, or the users, once they get the model periodically, they could reconstruct the model. It has been shown feasible in some contexts. So now, there is a nice trend using trusted execution environment. I don't know if you heard about it, but it's basically a place in your CPU where not even the kernel or the root or whoever in the device could look into because it's hardware enforced. And so that seems amazing, but the problem is that that's very small. And you definitely won't fit models inside that or a full model inside that. So can we leverage TE for federated learning so to make a fully private end-to-end system? And the answer seems to be yes, and that's a quick overview of our idea. So we assume a server and a set of clients, both equipped with TE. So you can bootstrap the model with public knowledge, based on the public dataset so that you don't disclose anything. You freeze the first layer, which is mostly future extraction anyway, so that's good enough. And then you start layer by layer training the next layers. And you encrypt between TEs, and then you encrypt once you have done, and then you freeze the level. You can have, instead of one layer, 2 or 3, depends on how big the model is and how big your TE is, that's configurable. But in this way, all the other attacks, and I'm going to give you a reference to the paper, has been shown that gets random guessings. So this is protected against that. So yeah, this is a bit, again, the story of this one. So we implemented it and we tested it, and so I told you, we showed that actually this protects against all the private, or the known, at least I would say, privacy-related attack. I'm sure there will be more fancy attack that might come up with it. And the model utility remains the same, actually with less communication costs. We have shown that, but that's a side effect. Layer by layer could improve even some performance, but that's because of the model itself. And the system cost is fairly limited with respect to the vanilla federated learning. And the fact that you can do this multi-layer, it gives you flexibility in the terms of what you want, the way you want to tune the system. Code is available, more reference here in case you are interested in more details about this specific work. So 3 takeaway plus 2 additional later on. So I hope I sort of convinced you that there is in this interaction AI and networks. They can be beneficial for both, for AI and for the networks, but there are still a lot of challenges ahead. And why we mentioned specific about the privacy, it's interesting to have this sort of community events where we share many of the thoughts and actually we share many of the pains and of the good inside about it. There is a paper which does more or less cover about all of the insights about this talk. And the two things that I want to tell you is that we are also heavily hiring in the area, so please, if you're interested, please ask me and let me know. And I forgot the second one, so. Thanks.
Thank you, Diego. Any questions? Thanks for the talk. I have a question about this training you were showing in this federated learning. Yeah, I don't understand fully how this block training works, because what's your output? How do you backpropagate any kind of gradient there? Or how do you work?
So you train layer by layer. So you freeze the first layer and the last layer, and you train each layer. And then once you optimize it, you move it, you freeze it, and you go on like that.
So you freeze the layers at the end, so you can have the output you want to predict.
And then you move and you optimize each one.
Okay, cool.
And basically, all the training happens in the TE, so it's protected, and there is no way to look into it even from root, even if you're rooted phone or rooted server. So basically, everything happens inside, and it's fully privacy preserving for that way. If you don't do side channels attack, but that's a different thing.
Okay, thanks.
So in that case, just to make it a bit clear, no data is transferred between the user and the server. Okay.
So the gradients are transferred between TE and TEs, but encrypted. So that only
they're still encrypted.
It's encrypted. So basically, even you looking at what's happening in the communication, you don't see the weights.
Okay.
Only the two TE can see the weights. You have to bootstrap the keys, and using one of the traditional systems for bootstrapping the keys, and then only the TEs can see it. And whenever you freeze it, you also encrypt it so that it can still be stored outside and be encrypted.
And then the weights are shared to the main model, I guess.
The main model is built and shared back to the users.
Okay.
So if you don't trust the user, then you might want to encrypt it as well and just infer it loading in the TE. Okay. But that's that's a design. Depends on your assumption.
So if there are no more questions, then thanks again, Diego. That was a very interesting talk.